All right, thank you. So we can begin now.
Okay. Okay, sir. Okay, sir. Okay. Please, should I start from rejection of a
Eh,
result?
Yes, please. Yeah, yeah.
Okay. If you perform a series of replicate analysis, you may find one of the results that appears to differ mark, markedly from the others. You will learn. You will then have to make a decision whether to reject or retain it. What you will realize is that there are some there are no uniform criteria that you can use to decide whether a suspect result a suspect a suspect result is due to accidental error or chance variation. The only reliable way that you can reject a result is when you can assign a specific error that leads to the doubtful result. On the other, on the hand, there are a wide variety of tests that can enable you to determine whether a result should be rejected or not. One of one of such statistical tool is the CHE test. The CHE test is one of the several suggested statistical tests for rejection of a result. It is statistically correct for a fairly small number of results. A ratio CHE is calculated by arranging the data in decreasing order of numbers. Then the difference between the doubtful number and its nearest neighbor is divided by the range, that is the difference between the highest number and the lowest number. For you to make for you to make judgment for you to make judgment, you have to compare your calculated ratio CHE with a tabulated value of CHE. If the calculated CHE is equal or greater than the tabulated value, then the doubtful result can be rejected. The table 2.1 below shows values of CHE at 90% confidence level.
Okay, so let me just chip in. This is more or less like a straightforward thing, which will just help us. So basically, what we're trying to say is, as you know, maybe precision or maybe accuracy. It's more or less like how close numbers maybe are to each other, as maybe when you are doing a series of calculations or maybe an experiment. So, like the Q test will just help us know whether a particular value that we obtained, let's say in an experiment, should be accepted or not. So maybe, yeah, so let's get into the example. Then maybe we'll probably get maybe the true understanding. So basically, this is, let's say, the table. So depending on how many times you did the experiments, so that's the number of observations, maybe depending on how many values that you got, right? If you got 3, then it means maybe this would be the corresponding Q value. If you had 4 observations, this is the corresponding Q value. If you had 5, corresponding Q value. So basically, this is how it is. Just like per what he read, if you had to get a value which falls within the Q value, that is maybe less than the Q value, then that particular result can be accepted. So maybe we can see the value that we got from the experiment can be accepted. Whereas if you get a value which is higher than the Q value, then that particular value that you obtained can be rejected. So basically, is someone's hands up. I heard a sound. Usually that means someone has a question. Okay, sure. Sorry. Um, okay. So, Mr. Sapon, let's get into the question. You can just read the question. Then.
Okay, please, the question. Is it, should I start from the example? The following set of chloride analysis on, should I start from that point?
Yeah. You
Okay.
can.
The following set of chloride analysis on separate aliquots of a pooled serum was reported. One value appears doubtful. Determine if it can be ascribed to accidental error. 103, 106, 107, 114 ppm. Then the solution. Certainly, the doubtful result is 114. It differs from its nearest neighbor. That is 107 by 7 ppm. The range of this result is 114 to 103, 103 ppm, and is equal to 11 ppm.
Hi,
Yeah.
okay, don't. Sorry. Let me just chip in. So this is like a bit straightforward. Do you get it? Prepare what he read. Maybe there was an experiment, and these are the four values that was what obtained: 103, 106, 107, and 114 ppm. That's part of a million. So basically, from these values, maybe to the human brain or something, right? If maybe we are talking about precision or accuracy, we would say maybe 106, 107 are like maybe a bit precise because they are close. 103 is not that far from 106. Maybe it's also pretty close. Do you get it? So it's like maybe per the human brain, we can just assume these are the maybe three values that maybe are right from the experiment that maybe the individual did. But then we can't certainly say 114 should be rejected or not. That's when the Q test comes in. So the Q test is just going to help us determine whether or not 114 parts per million is maybe a right reading from the experiment that was carried about or not. Do you understand? So basically, per what we've read, you just find the difference between the doubtful value in this case, which is 114, right, from the closest. So sorry, from the like from the closest value to it or the nearest value. So in this case, it was what 107. So I'm just going to find the difference between 114 and 107, and that's what we see here, which is 7 parts per million. Then afterwards, you find the range. So the range is simply subtracting the sort of the doubtful value, right? Maybe subtracting the first value. That's if you have to arrange them, subtracting the first value from the doubtful value, and that is what we have here. And afterwards, you just divide the value that you obtain when you subtracted the closest value to the doubtful value over the range that you obtained. That is what we got here. So from this, what we are getting here is what 0.64. Then you come back to the table. So now the table gives us the number of observations. So assuming the results here were just 3, then you would look for the Q value, which is based on 3 number of observations. But in this situation, the number of observations are 4. So then you come to the Q value based on the what? 4 number of observations. So from what we are seeing here, this is 0.76, and the value that we calculated is was 0.64. So since the rule states that any value that you obtain should be accepted. When it falls within the kill value, then it means the 0.64 can be accepted. I don't know if you guys get this. I'm just going to give you a similar questions, maybe the same example, but this time around I'm going to give you different values. So the values are, please write it down, and maybe you guys will solve and you give me the answer. So the values are you ready to take the question, please? The same question, I'm just going to give you different answers. So just give me, sorry, different values. So just give me a thumbs up if you guys are ready to take the value, so you can just work it out for me. Okay, so the values 109, 110, 112, 115, then 122. So 109, 110, 112, 115, then 122. Hope you guys got the question. All right, sure. Okay. So just within a minute, the first person to get the answer will get Tom from me. So I'll be waiting. Oh, Mr. Alex was the Tom. Okay, that's nice. Okay. Mr. Alex, I'm waiting on you.
I can't see the slide. My
Okay, okay,
screen.
okay. Okay, sure. You can. Okay, okay. The Q value, sorry. Um, okay, Mr. George. Oh, yes.
Okay, let me give you my answer if I'm correct. I got 0.076.
Okay. How did you get to that answer? 0.076. How did you get the answer?
Okay, if I understand, I subtracted 109 from 1010, 110,
Okay.
and then after that I subtracted. I find the range from 109 from 1 to 2.
Okay.
Then after that, I divided 1 by the range.
Okay. Okay, sure. Okay. Anyone with a different answer? So George, we come back to you. Thank you. Anyone with a different answer?
Okay.
Hello. No one wants the Tom. Hello. Anyone else with a different answer aside Mr. George?
Hello, sir.
Hi, Mr.
Please,
Williams.
I went off when you were giving out the figures, so I couldn't get it. If I can get it now,
Okay,
sorry.
109, 110, 112, 115, 122. Are you okay?
Please, if you can come again, sorry.
109, 110, 112, 115, 122. Okay. Should I continue or someone has a different answer? And just show by hand, I'll call you. Okay, sure. Mr. George, so okay. So let's go through. So you said you subtracted 109 from 110. That's what you said, right?
Yes, sir.
Okay. So meaning you which value you see per what we read, right? You first have to determine the value which might not be the right value. Do you understand?
Okay, sir.
Like in precision, the values are sort of close to each other. Maybe accuracy, the values are close to each other. So now the first thing to do is to determine which value, right? To determine which value might not be the right value. Do you understand? So you
Okay,
choose
sir.
110, sorry, 110. Why did you choose 110?
Okay, I thought per the explanation you said you subtract the numbers that are nearest. So
Okay.
I didn't get it the way you are saying.
Okay. Okay. Sure, don't worry. So okay, that's like probably network glitch. Mr. Williams, I can see your hands up. You can talk to me.
Yeah, all right. So the figures that was given us 109, 110, 112, 115, and then 122. And if you compare the figures, when you look at 109 to 110, it's closer to each other. So the difference is just one. Then when you look at that of 110 to 112, I think it's sequence, but after the 115, the next number that you can see is 122, which is a little bit far different from the rest of the figures being given. So when you look at that one, you can determine your range from the last digit, which is 115, to that of the 112 is 7. So you get 7 from there. Then you come and subtract the first digit, which is 109, from that of the last digit, which we identify as the different one from the figures. That is 122. So by subtracting, you get 13. So by so doing, you use the range, which is 7, divided the 7, that is the ppm, divided by the 13, and you get 0.538, and you can run it to be 0.54.
Okay. All right.
Yeah.
Thank you. Okay. So are you guys okay now?
Okay, I get it now.
Okay. So Georgia, okay. So last another question. The same preamble. I'm giving you different values. So the values this time, um, one one, sorry, 132. I'm calling out now. 132.
So the first one is 132.
Yeah, 132. 132.
Another
One.
132.
No. So 132, 124, 125, 126, 122, then 120. So 132, 124, 125, 126, 122, 120. Mr. Williams, your hands are up.
There's George.
Okay.
I got 0.5.
0.5. Okay. How did you get or derive your answer?
Okay, so I subtracted 126 from 132, and then
Okay.
I got 6, and then after getting the range, which is 12, so
Okay.
that is I subtracted 132, 120 from 132, and I got
Okay.
12, and then I divided the 6 by the range.
Okay. All right. Thank you. Do you guys agree, or you guys have a different answer? Pick one. Anyone with a different answer? Okay.
Sir,
Aboti Edem. Hi.
they also had a 0.5,
Okay.
but I didn't get. I have when I subtracted 124 from 126,
Okay.
I had 2,
Okay.
and I now find the range, which is 132 minus 124,
Okay.
which gives me 8.
Okay.
So when I divide 2 by 8, I divide 2 by 8, and that's giving me 0.25.
Okay. Sure. Okay. So, okay, thanks, Mr. Edem. So let's say in an examination, right? Okay, so why did you choose that range 124? Why did you choose that range? Why 124 minus 126? Is that him? Hello.
Hello, sir.
Yeah, I was asking
Hello.
why you choose 124 and
I
126.
think
That's what you
one
said,
to
right? You
yes,
subtracted
please.
124 from 126. Why?
exactly. So I was looking at the range. I decided to arrange it from the smallest to the biggest. That's in ascending order.
Mhm.
So
So that's
I,
120 to 132, right?
the first one is 124.
No, the first
We
value
had
I quoted was 132.
exactly.
Okay, so
Then
you had
one,
124.
yes, the first one is 132, followed by 124, followed by
Yes,
125, and then 126.
yes.
So I now arrange it in a ascending order.
Okay.
And when you look at 124, 125, and 126,
Mm-hmm.
the interval or the difference among them is 1 1.
Yes.
But the number which is quite far from those ones is 132. So
Yes.
per the first example that we did,
Yes.
I subtracted those that are close. That is the smallest from the bigger one. That is 124 from the 126, which gives me 2. Then I now
Okay.
subtracted the bigger, the small one. That is the smaller, which is 124 from the highest one, which is the 132, which gives me 8. Then I do
Okay.
that. And that's what I do. Per my understanding, sir.
Okay. Okay. I get you. But then that's not how it's supposed to be. So maybe yes, you got the answer, but then at the end of the day, the how you got the answer also counts. Do you get it? Uh-huh. So maybe okay, what we spoke, say Stephen, your answer up. Mr. Stephen Penu, if I'm not butchering your
Yes, sir.
name.
Yes, sir.
Hi.
Please, that's my. Sir,
Okay.
please, to be frank, I'm not getting anything. And in order to if like you can manage some things for us, so that we will be seeing the way things will be calculated and things.
Come again. I
So
can barely hear you. What are you saying?
I'm saying that I'm not getting anything at all. And
You're not
what
what?
I seem to be, I'm not getting anything. I'm not
Okay.
understanding what is going on. So
Okay.
if you can be writing it, we will. I'll be happy to see it that way
Okay.
because I'm not getting anything, please.
Okay. Okay. Sure. 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 So how can I be right? I think one time, one guy used some. I don't know whether it was an app, but okay. You. I think let me just try and use Word today. Let me see if that would be possible. Just for us to go through. All right. Okay. Okay. So we can see my screen. So I think the values I gave were 132, 124, 125, 126, 122. Sorry, 122, and let's say 120. Right. So you're going to answer all the questions. So Mr. Adam, so maybe from this, as you said, we have first have to arrange it in ascending order. So 120, 122, 124, 125, 126, 132. So now maybe we've arranged them in ascending order, right? Now what you have to look out for, it's not about the maybe yes the differences count, but then that's why with the first example I stated that maybe to the human brain, if you are talking about precision and accuracy, right? Please
Sir,
mute yourself. Hi.
sir,
Hi.
my hand has been up. Like I was on transit before everything was going on. So I just want to know what we are calculating so that I can maybe relate and follow.
We are doing the kill test. The kill test. That's what we are on.
All right.
Okay. All right. Sure. Okay. So let's get back to it. Sorry. So 120, 122. So what we have to look out for, as I said from the onset, is to the human brain. If you are talking about precision and accuracy, we know it's like how close numbers are to each other. So now if I'm giving values like this, right, the first thing that would come to mind is the odd number out is automatically going to be like the 132, because maybe if I'm talking about precision and maybe accuracy, 120 is a bit close to 122, 122 is a bit close to 124, 124 to 125, 125 to 126. See, these numbers are close to each other, so there may be only odd number out here is sort of 132, right? But then maybe we are doing, maybe we're carrying out an experiment. So let's say we are using um, an analytical balance and all that, right? And maybe these are the values that we obtained. Now we know human errors can play a part when we are maybe weighing and all that. But then what the Q test is saying is, in as much as human errors can play a part when we are doing experiments, we can't maybe humanly say that a value that was obtained during an experiment is not a right value. Please, are you guys understanding it? That's
Yes,
what
sir.
the Q test is saying. So since we can't humanly predict that a given value is to be rejected or accepted, then we are going to use the Q test to determine whether a given value or an obtained value should be rejected or accepted. So now using my maybe like on a normal day, I would just assume 132 is the odd number, because these numbers, that's 120 to 126, are a bit close together. So since 132 is the odd number, I think should be rejected. Q test is saying you first have to subtract the closest number. Right. The sorry. Sorry. You first have to subtract the closest number. The closest number, which is sorry, close to the 132. That's the first thing we have to do. So now the closest number from what we've done is what, 126. So that gives us 132 minus 126, since it's the closest. When we say closest, maybe pay the value that maybe pay what we did here. 126 was not even close, but then let's say from 126 we go to 132, so maybe that's the closest number to the 132. So now assuming you didn't rearrange it, right, the closest is more or less like then so from here. So I don't know, I don't want to confuse you, assuming, so just like, okay, Mr. Adam arranged it, but maybe we can meet someone who wouldn't like to arrange this in ascending order. So assuming you didn't arrange it this way, but rather you are just going directly using the question that was given, right? The closest number, when I say, is not 124, but rather a number whose difference, right, to 132 won't be that high. So even though 124 is close to 132 from this question, the difference between 132 and 124 would be high. But then the difference between 132 and 126 won't be that high. So that's what I mean when I say the closest number to 132. So if you had to rearrange it, then it will be, yes, the number which is maybe directly next in line to 132. But assuming you don't rearrange it, then it will just be based on the difference. That's what I'm trying to say. So now if you have to find the difference between 132 and 126, right? What answer do you get? Okay, what we did. The answer here is what, 6, right? It's not 6. That's the answer you're going to get, 6. So now,
Yeah, 6.
yes. So after this one, the Q test is saying after getting maybe the difference between the odd number and the closest number to the odd number, you then find a range. So the range is more or less like, after arranging in ascending order, the least, right? The range is just subtracting the least number from the odd number. So in this case, our least number is what, 120, whereas our odd number is 132. So I'm just going to go ahead and do the math, which is 132 minus 120. Sorry. minus 120. That gives us, shoot,
Twelve.
sorry, that gives us 12.
12.
Yes, 12. So after getting this, Q then becomes, right, the Q value then becomes 6 divided by 12. That is the difference between the closest number to 132 divided by the difference, that's the range that you got. And that gives us the 0.5 that Mr. George got, as well as Mr. Edem, even though his way was like an Obinim way. Probably used an Obinim sticker to get that answer, but that's just by the way, I'm sorry. So now after obtaining this value, 0.5, there's the value that you've gotten as the Q value. You then come back towards the Q table, right? So this will be provided for you. It's not like you have to chew this off here, please. This will be provided for you. You just have to know how to calculate for the Q, but this table will be provided for you. So now the values that were given are 1, 2, 3, 4, 5, and 6. 6 values. That means the number of observations becomes what? 6. And now from the number of observations 6, the Q value is what? 0.56. And from the rule, if the number calculated, right, if the Q value calculated is less than the Q value on maybe the Q table, then that particular value that was obtained should be accepted. So now in this case, per our calculation, we go with 0.5 to be our Q value. And per what we have from the table, for the number of observations 6, the Q value is 0.56. So now since 0.5 is less than 0.56, then we can what? Accept the value that we had, which is 132 in the experiment. Please, are you guys okay? To those who just joined, please, are you okay up to this point? Thumbs up if you're okay up to this point. Okay, beside them, I can still see your hands up. Are you okay now?
Sir, please say that part again.
So I should say which part again?
The latter part, the conclusion that you have just made.
Okay, sure. So, okay. So you got it up to where we calculated for the Q value, which is 0.5, right?
Please, yes. Yes.
Yes. So I'm saying after calculating for the Q, right? The Q value, you come back to the table. Now I'm saying this table will be provided for you during the exams. So you come back to the table, and on the table you see there are different number of observations. So the first thing you look out for is how many observations maybe was provided. So from this you had 1, 2, 3, 4, 5, 6, meaning the number of observations are what? 6. So now you come to the table, you look for the number of observations, which is 6 here, and then you look at the value. So the value for the 6 number of observations was 0.56, and then 0.56. So the value, right, is 0.56, whereas our calculated value is 0.5. So since our calculated value is less than the Q value on the table, right, then we can say 132 should be accepted. Do you get it? Because the value for the Q calculated for the 132 is less than the Q value on the table. Please, you understand?
Okay. Yeah.
Yeah, okay,
Thank
now.
you. Yeah. Thank you.
All right. Okay, sure. Thank you. Okay, so we can continue.
Yeah.
All right.
Sir, please wait. Sir,
Hi.
so it means this test is this is calculated for us to determine whether a test an experiment should be accepted. Is that what it means?
Yes, a particular value in an experiment should be accepted. That's based on precision and accuracy. Do you get it?
Oh, okay.
All right. Okay. Thank you. Welcome back. Welcome back. Mr. George, do you want to continue or Miss Anita should take her place? I don't want it to be like I'm selling you out or something.
No, he should continue.
Okay. Yeah. Oh, let Anita continue. I just took my medication, so
Okay. Mr. Sylvester, I can see your hands up. Sylvester Mausi Bozo.
or Anita, you want me to continue?
Oh yes, continue. Okay, I'll take it
Okay.
next week.
No, let me continue more, and then you come
Okay.
in.
Yeah, please hold on.
Come
Before
in.
you continue, Mr. Sylvester, I can see your hands up. Do you want to say something?
Sir, I want
Okay.
to ask for the sake
Hi.
of examination, sir.
Okay.
Sir, hello.
Yeah, I can hear you.
Uh-huh.
I can
For the
hear
sake
you.
of, for the sake of examination, that table that is having the values of
Yeah.
the Q, where we have a number of observation to be 0.4, the observation is 3, and the Q value is 0.94. For the sake of examination, would that table be given
Yeah.
to us before we do our calculation to relate it to
Yes.
it to know if it is? Yes, sir.
Yes, please. Yes. The table will be
Mm-hmm.
provided.
Okay.
You don't have to learn the table of it. It will be provided. Do you understand? It's like a
Oh, oh,
standard. It's like a standard thing. So it will be provided for you, please.
okay. Thank you.
Okay. All right. Thank you, Mr. George. Let's go back. I'm stuck with you today, so let's go back. All right. Hello.
Hello, sir.
Hi. Okay. So we can go back. Let's continue.
Okay. So I'm continuing from
So the TN test.
okay. In the American Society for Testing Materials, that is ASTM, TN test, the quality TN serves as the rejection criterion where the formula, should I quote the formula?
No, don't worry.
Okay. Here, XQ is the questionable result and X bar and S are the mean and standard deviations of the entire set, including the questionable results. You can only reject the questionable result if Tn is greater than a certain critical values as indicated in the table 2.2 below. Table 2.2, critical values for rejection quotient Tn. So that is the table.
Okay. All right. So this is
Example.
also, yeah, I'm coming. This is similar to the KO test that we just did. Do you get it? So the same way a table will be given to you, and basically you just do the maths, and at the end of the day you just um, find the confidence level, just like we did for the KO test. So let's get into the example.
Example, the analysis of a calcite sample yielded calcium oxide percentages, that is 55.95, 56.00, 56.04, 56.08, and 56.23. The last value appears anomalous on the basis of TN test. Should it be retained or rejected?
Okay. Okay, so you guys get a question? Do you guys get a question, please? Hello?
Yes, sir.
Okay, sure. So this first, you have to know how to calculate standard deviations. I believe we can all calculate standard deviation, right? And we can all find the mean in a given, maybe when you are given a set of values. So basically, that's what we have to do here, calculating the mean, and at the end of the day, calculating the standard deviation. After calculating the mean and calculating the standard deviation, you just come in with substitute in the TN formula, right? And after substituting into the TN formula, the value you would get, you just bring it back to the table based on the number of observations that was given. You can determine whether the particular value would be what retained or rejected. That's basically what we are saying for this one. Would you guys want us to break it down, or you are okay with what I just said?
Please break it down. Break it down.
Yeah, can't you break it down?
I should break it down. Okay.
Yes,
Okay, sure. So this is the question, right? The analysis of cow size, blah blah blah. The values are 55.95, 56, 56.04, 56.08, and 56.23. So now, sorry, these from these values given, do you get it? If we are to talk about precision and accuracy in these values given, you can see that 55.95 and 56, like they are a bit close, right? As in terms of like how close they are to each other, they are a bit close. So the same way, the odd value or the value which we would throw into question becomes this, which is the 56.23, because the difference between like the 56.23 from the rest is like quite huge. But this one, unlike the Q test, you're not going to find the difference between the 56 and the closest value to it, right? But rather, you are first going to find the mean of the number of the given number of observations. Yeah, okay. Okay, let's continue. So you find the mean of the given number of observations. Then after finding the mean, like that's one set. So like on the table, this is the mean. So you find the mean here, and at the end of the day, you go ahead to find the standard deviation. I believe we all know the formula for finding standard deviation. Hello, hello. I
Hello,
can't use
hello.
I can't use word to write it for you guys. So okay, let me just use Chrome to give it to you. Maybe for those of you who don't know the formula. Sorry. So for those of you who don't know the formula, you can just jot it down, right? So this is usually the standard deviation formula. So for those of you who don't know, please jot it down. I beg you. All right. So this is the standard deviation formula. So let's just go back into what we are doing. So you just find the standard deviation to, do you get it? And after finding the standard deviation, sorry. So one time there is this guy, I forgot, is it Mr. Robert? Think you were solving a particular question with the class. And I don't know whether you used an app, but you were able to use a pen, like as in a virtual pen, to do the calculation. Do you guys remember that time? I just want to find out who did it.
Yes, we remembered, but was
You
it
don't know the
Robert?
exact person. I'm thinking it was Robert. I don't know.
It's not Robert.
Okay.
It's not Robert.
Oh, okay.
I've forgotten the name. Mr.
Uh,
Mawi was reading and he asked that guy to take over.
Yeah. If I could get that guy to show me how he did it, I could have just done it
Uh,
as in like for
I
subsequent classes. Hi.
think you can equally when you open the models from Drive, Google Drive, you
Okay.
can equally put the pen over there. The icon is there. You can use it. The word that you've opened. The pen is also there that you can use.
Okay. Where? I've opened Word now. Where do I go to?
So
Uh-huh.
there is a note. You open to notes. When you get to where the note, you see a blank space there. Then you select the pen that you use.
Okay. Notes. Where do I see notes? I am lost. You can see my screen, right?
So where the you see the more or less like
I'm listening. Mr. Bright, if you guys can just show me,
Yes,
so I'll
please.
just do it. Uh-huh. Where do I go to?
I'm coming.
Okay.
Yes. Okay. I think yours is different.
Mine is different.
Yeah.
Oh. My word is different. Or but so can I use something else to do it? I don't know.
Sir, please, just right click your with your mouse. You will see some options there. Yeah,
Okay.
the pen down there.
Wait, is it a styles?
Ink. Is it yours? I can't see the screen. It should be ink something. Then you have to choose the
Format
point.
painter.
Yes.
Format painter.
No. It's like they'll write either ink or pen.
Wow. Uh,
Sir, please, do you
I'm
have
not
WPS on your laptop?
WPS. Oh, okay. I don't have WPS on the laptop.
WPS.
I don't have
Yeah.
WPS on the laptop.
Okay.
Oh, okay. Okay. So unless I download WPS, right?
Yeah.
Yes, please.
Okay.
Yes, please.
Okay. Okay, then I'd have to do that. Because of time, maybe for our next class, I would have downloaded it so we can use it. Do you get it? But for now, I just want you guys to stick with me. Like it's similar to the Q test. That's what I want you guys to understand. That the TN test is similar to the Q test. Just that in this case, we just use a different formula. So all you have to know is to memorize this formula of it because the formula won't be provided for you. So you just have to know the formula of it. After knowing the formula of it, the SQ here is basically the value. The SQ here is basically what the value we are assuming to be wrong, right? That's the SQ. Whereas this X here represents the mean, and the S just represents the standard deviation. So when the question is given, what you first have to do is find the mean, calculate the standard deviation, and at the end of the day, you just come in with substitute into the formula. Then any value that you get, you just come in with use it to um you just come and compare it with to the corresponding number of observations on the TN table, right? Then the same thing. The answer should be what accepted or rejected. Please, are you okay? I'll do the BPS, so next time I'll just use. Hello?
Hello, sir. It seems the network is not.
Hello.
It seems the network is not stable.
Yes, you
I'm
went off.
sorry. I'm sorry. MTN. I'm sorry. Sorry. Okay, sure. So
Sir,
let's continue. Hi.
please, which number you said we are the number we are assuming to be wrong? So how do you
Yes.
know, or which criteria would you use to assume the number?
So it's basically you just check all the numbers given and you just see how close they are to each other. Do you get it? So it's like basically that's how it is, like how close they are to each other. So in this case, like okay, or maybe you can just find the differences. Do you get it? In case you want it to be simple for you, you can just I'm coming. So let's just do this. Like these values that were given. Um, that's in case you can't maybe just tell from the values that were given, right? 55.95, 56, sorry, 59.55. Then we have 56, 56.0. And then we have 56.04. And we have 56.08. We have 56.24, sorry, 23. Right. So in this case, this already arranged for us, let's say in ascending order. So now in order to determine which value shouldn't be accepted, right? Shouldn't be maybe which value you are assuming not to be accepted. You can just choose to find the differences between maybe the numbers. So maybe you first find the difference between 55.9, right? Maybe assuming you just want to do it that way, you would find the difference, which is 55.9 minus 56 or 56 minus 59. You can find out that the difference is 0.1 for this particular one. Then maybe you find out the difference between 56.04 and 56. The difference becomes 0.04. Then you jot that one two down. That's in case you want to do it this way, 0.04. Then you find the difference between 56.08 then 56.04. The difference also was 0.04. Then you find the difference between the 56.23 given and there was 56.08. The difference becomes 0.15, right? So now if you are to like assuming this is what a calculation, right? And maybe we are talking about precision, and you can see that maybe this and this are close to each other, right? And let's say this and this, you can see they're a bit close, but then in the sorry, my battery, it's on charge. The as after arranging it in the ascending order, you can see that this are close as compared to how close they are to this particular value here, 0.15. I don't know whether this makes sense, but then usually it's just how the differences, that's how you would know. The differences between them, that's how you would know. Is someone's hands up? Okay, I can't see the screen. Oh, are you guys facing the same issue? You guys can't see my screen anymore?
We can see it. Okay, I can see.
Oh, okay, okay. All right, sure, thank you. But Miss Anita, do you understand to this point? So like
Yes,
you
sir.
just have to
I'm
find
okay.
them. So I give you are giving 1, 2, 3, 4, 5, 6, 7. Then after 1, 2, 3, 4, 5, 6, 7, you see 10. Sorry, you see maybe 15, right? You should just know 15 is the odd number because it's like it's very far from, do you understand? 7
Okay,
basically.
okay.
And that's how we like there is no particular criteria. You just have to know in a certain sense. Do you get it?
All right. Thank you.
Okay. All right, sure. Thank you. All right, so let's continue. Let's
Sir,
continue.
please, I can't see your screen.
You can't see my screen. Okay, I'm probably thinking it's your network. I don't know. So please uh, put your phone on
And
airplane mode and come back. Okay.
and
Mr. Job, you
Anita,
can see my screen. Uh-huh.
no, sir. I send a message. I can't see your screen. It's only O that is shown on my screen.
Okay,
So
I'm coming. Let
if
me
if
stop sharing and share again. I'm coming.
My twist like that.
Okay, I'm coming. I'm sharing again. Um, Okay. Okay. Can you see the screen now?
No,
No,
please.
sir.
Still.
No, sir.
Yes,
Maybe
yes, sir.
it's the network.
I
Okay.
think it's
Maybe it
network.
might be my.
Because some of us
Okay. It
can.
might be my network. Okay. Okay.
Anita,
Yes.
if you can see, then you continue for me because I can't see.
I'm coming. Let me just switch internet connections and see. Okay. I'm coming. Okay. So is it better now?
No, sir.
Still
No, no.
okay, then I'm taking this from your networks because
Yeah, it was about to rain at my end here, so I don't know if the network has
probably that's why
jammed.
that's why. Then it's your network. Okay. Miss Anita, that means we are finally back together. Welcome back. So let's continue.
Okay. That's session 3.
I feel Mr. George intentionally prayed for it to rain, but then no worries. You can continue.
Detection of systematic errors. In session 3 of Unit 2, you will know more about errors, particularly determine errors. You remember these errors are of generally predictable pattern. It is therefore possible to be able to trace the source of the error and, if possible, effect some remedies. General overview of detecting and minimizing determinant errors. If you later realize that your 25 milliliters pipette delivers only 20 milliliters of liquid, then you can always make appropriate corrections on the volume of a liquid delivered using the pipette repeatedly. Generally, some systematic instrumental errors can be found and corrected by calibration. You must periodically calibrate your instrument because the response of okay. You must periodically calibrate your instrument because the response of most instruments change with time as a result of aging, corrosion, or mistreatment. As we illustrated in the session 2 of this unit, some systematic errors may involve interferences where a species present in the sample affects the response of the analyte. Definitely, you will not expect that a simple calibration will compensate for these effects. For instance, it may require that you change the entire method, mask the interference, or do prior separation before analysis. For those systematic errors that originate from you as the analyst, you can minimize them through careful and disciplined laboratory work. It is a good habit for you to always check instrument readings, notebook entries, and calculations systematically. You sometimes limit your personal errors, especially those of bias, by using an automated procedure. In the next sub-sessions, you'll be introduced to some steps that you can take to recognize and adjust for a systematic error in analytical method. So kindly go up for me.
Yeah.
Analysis of standard samples. The best way that you can estimate the bias in an analytical method is to analyze standard reference materials, that's SRMS. Do you know what SRMS are? Remember in Unit 1 that we have special purpose reagents. SRMS are special purpose reagents that contain one or more analytes at known concentration levels. Standard reference materials, that's SRMS, can be purchased from a number of governmental and industrial sources. You learned about some of these sources for special purpose reagents in Unit 1. Once again, the National Institute of Standards and Technology (NIST) offers over 1,300 standard reference materials including rocks and minerals, gas mixtures, glasses, hydrocarbon mixtures, polymers, urban dust, rainwater and river sediments. What you will realize in your experimental work is that the results of analysis of the standard reference materials often gives results that differ from the accepted value. When this happens, your task will then be to establish whether the difference originates from a systematic error or a random error. We shall discuss such decision-making process in a later session of the unit. Independent analysis. In cases where you do not have standard reference materials readily available, you can use a second independent and reliable analytical method for the analysis. The second method should be carried out in parallel with the first that you intend to evaluate. One thing that you ensure is that the two methods should differ as much as possible to the extent that common factors in the sample should not have the same effect on the methods. For instance, in the determination of potassium in a sample using flame emission spectroscopy unit, that's unit 5, sodium is a major interference. However, in the potentiometric determination of potassium using an ion selective electrodes based on crown ether, that's unit 5, sodium does not interfere. So you can run the potentiometric method parallel to the spectroscopic method. Just like the use of standard reference also require a statistical
Hello? Hello? Am I the one not here? Hello, can you guys hear me?
Yes,
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 please.
Okay.
Yeah,
Anita is
you can hear you, sir.
okay, sure. So what she's reading is that's basically what the book is trying to say. Like we are going to learn more about these things as we go further down the line. You understand? So because of time, I wouldn't like us to even continue reading. I just want us to continue. We'll come back to this. Like when we get to the chromatography and the spectroscopy, we are going to tackle all these things. So don't worry. We can.
bias
Are you back,
or
right?
random error. Blank.
Hello.
Okay, it was off. The
Hello.
screen went off on my end. Hello.
Okay, you are back now. All right, sure. So let's
Yeah.
get into the random errors in chemical analysis. Let's get into that. Okay,
Random
I'm coming.
errors in chemical
Please hold on. I'm coming. Let me just
analysis.
see if I. Uh-huh. Um, okay, Madam Gifty.
Sir, please, you've stopped sharing your screen from my end.
Hey, but you can see my screen.
Is
It's
the
not me. Oh.
is the
No,
network
please,
you?
can't see it.
It's network.
Madam
Network,
Gift,
please.
is the network you? We are also experiencing the same thing here.
Oh, okay, Sir George.
Okay. Sorry, I'm coming. I'm trying to get the WPS. Sorry. Because of what we are coming to do for the next one, I'm just trying to get it so that I can write and put it that way. All right, so let's continue. Sorry, the download will be. I'm coming. A minute. Sorry, let me just install this right now and see. Yeah, this would work. Install. Okay, so let's continue, please. Okay. Anita, please let's continue.
The WPS of it. Okay. Okay, random errors in chemical analysis. No matter what you do as an experimenter, why is the thing off? It's back.
Okay.
No matter what you do as an experimenter, random errors will always be present in every measurement that you make. In this session, we will try to trace their sources, determine their magnitude, and finally, discuss their effect on chemical analysis. Nature of random errors. The major source of uncertainty in any of your measurements is due to random errors. You can easily control the variables that cause them during measurements. This makes it impossible for you, even if you can identify their source, you cannot measure them. This is because the individual random errors are usually very small. However, their accumulative effect causes replicate results to fluctuate randomly around the mean. Combination of random error sources. You can get a qualitative idea of the way small and undetectable uncertainty produce a detectable random error by considering the following scenario. Imagine a case in which 4 small random errors combine to give an overall error. Further assume that each error has equal probability of occurring and each can cause the final result to be high or low by a fixed amount, plus or negative u. You can work out possible combination of these errors below. That's table 2.3. Possible combinations of 4 equal sized uncertainty.
Okay. So I want us to go through this one. It looks homogeneous. I'm sorry, but let me see. I don't know that WPS is done. Is this the right thing I'm downloading? Or it's not the right thing?
No, please. So this is not the right thing.
Oh, and you've made me download it. Oh, my boss. What about this one? Is this one okay? Get into PC. WPS office. Or this one is not the right thing? The right. If you let me download this one,
Can
it's
I
not
see
right.
the icon? I want to see the icon.
I'm downloading from Get Into PC, so I don't know whether you can see it. I don't know. Hey, let me cancel this one before.
Yeah, I'm showing you one. I don't know whether you can see it clearly. It's like this. I'm showing you one on my. I don't know.
Okay.
Okay.
It's red.
Yeah.
No, it's red. Like okay.
And then the W sign is in it.
Yes. No, so like I know WPS, but I just let me see.
Like this one.
Okay. Yeah, I've seen it. I've seen it.
Mhm.
Okay, I've seen it. I've seen it. Yes, I didn't download the right one. I'm sorry. This one too is taking forever to download. But you let's just do something. Let's do something. Let's do something. Okay. So let's do something. So now from this table, right? We are just going to go through this table. Oh, Charlie, what's happening? It's showing here to, let me see. Yeah. Yeah. Okay, I'm coming. Sorry. Sorry, let's just do it. So now from the table, maybe from what Miss Charlie, what's happening? Okay. Hello guys, so is this what product key? No, I don't have any product key. Am I in the right place? Hello.
Yes, I think.
Am I in the right place? I'm lost. I don't know what I'm doing here.
You are, sir.
Okay. Okay. There they are saying I should upgrade now there.
This is shall agree. Oh, okay. It's
I say
new.
I need pro. It's okay. Don't worry. We'll have time for this one. All right. Let's just do something. So this is the table given, right? Per what Auntie Anita read, right? So these are the combinations of uncertainty, magnitude of random error, number of combinations, relative frequency. So now you can see 16 here. I just want us to rush through it quickly. The 16 here is because the number of combinations of uncertainty are 15. That's the first thing. That's why we have. So in case someone is waiting to ask me why do they have 16 here? The 16 is because the combinations of uncertainty are with 16. That is the first thing you guys have to know, right? Fine. So now we are like we've established why we have 16. Then the magnitude of random error. So the magnitude of random error is usually from what the combinations of uncertainty. So now if you watch here, we have maybe positive U1, right? Plus maybe U2 plus U3 plus U4. So now if you had to add all this, like if you are adding all this, it gives you the total of what 4U, right? So that's why we have a magnitude of random error here as what's for you, because 1 plus 1 plus 1 plus 1, that gives you a 4 from our math. So 4 and the number of u, so 4u, and the number of combinations. The number of combinations is simply how we can change this. Do you get it? That's usually the number of combinations, how we can change it. This is just positive signs throughout. So since it's just positive signs throughout, then it means you can't really change this in any way. Because if you had to put a positive sign here, like you're still going to get the same result. Let me put it that way. You are still going to probably get the same result because the positive sign will run through. You get it? That's why the number of combinations is 1 here. So then in order to find the relative frequency, you are going to just divide the number of combinations by the total number of combinations of what uncertainty, which as I said earlier is 16. So you're just going to get 1 divided by 16, which is what we have here. And when you come here, the magnitude of random error here is 2. 2 because -1, right? So there's a negative sign here. So this is -1 plus 1 plus 1 plus 1. So this negative one takes off what the positive one here. So that means this becomes u1 and u2. By adding u1 and u2, you get what? 0. That means you are just going to get u3 plus u4. That is 1 plus 1. That gives you 2. So that's why we have 2 here. Then the number of combinations. So the number of combinations are 4 because now you have what? Negative u1 over here. So since you have negative u1, the negative can what? Run through. So we can have what? A combination whereby you wouldn't have negative u1, but rather you have what? Negative u2. You can have a combination where you would have a negative u3, and you can have a combination where you have a negative u4. So that's basically why we got the number of combinations for this particular one to be what? 4, because the negative sign can what? Interchange. That's from u1 to u2 to u3 to u4. Hi, please, are you guys okay up to this point? Okay, Mr. Jacob, your hands up. Yeah, I'm listening.
Thank you, sir.
Your hands up. Hi.
Please, with this, what do you call it? Combination of uncertainty errors you're talking of, which is 16. I'm still confused how you came by the 16.
Okay, you are still confused how I came by the 16. Okay.
Yes, sir.
So, sorry. All right. As I said, when we began, right, I was like, the 16 here, do you get it? It's just based on the combinations of uncertainty. And now the combinations of uncertainty, from the little I've said, is just based on the signs, which is the plus or minus, as maybe we read from what Auntie Anita said, right? It's just based on the plus or minus. So now, if you are to watch maybe the combinations of uncertainty, let's just count it. You see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Do you understand me? So we are saying based on our plus, as stated over here, plus or minus u, we can get a combinations of uncertainty 16 times. That's what we are saying. Do you get it? That the combination of uncertainty that we can derive based on the plus or minus u, right, is 16 times. Is that okay? Hello?
I'm still lost. Yeah, I'm
I'll
still lost.
I'll
I'm
continue.
not,
Don't worry.
because you're saying,
Don't worry.
all right.
Okay, what are you saying?
So please, I'm not getting it too.
Hi. Hi.
Because we are not seeing your screen, so we don't know what you are calculating.
Do you guys have the slides? I thought you guys had the slides. Or I should post it on a WhatsApp platform for you.
Yeah, we've opened the slide, the model, but actually we are not getting the exact position that you are counting.
Okay. Page 49. Page 49. Open to page 49, please.
Unit 2 or 4.
But where you calculated and get the 16?
Yes, so that's what I'm trying to let
where
you guys. That's what I'm trying to get you guys to understand. You get it? That the combinations of uncertainty, right, is based on what Auntie Anita read here. That we can get a plus or minus u. Do you guys get that fact? That's what we are saying. It's based on the plus or minus u. That's the first thing you should know. It's based on the what? Plus or minus u. So now, since we are saying u can be positive or negative, right? Let's find out how many times maybe u can be positive, how many times maybe u can be what's negative. Do you get it? So the number of times maybe the plus and minus sign can affect, do you get it? The u is 1. That's what I've been saying. 1. Then you come here 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I'm saying this is how we derived the 16 that you see at the
Okay.
relative frequency. Are you guys
Okay.
okay?
Okay. Yes.
Yeah, okay to this point. Yes.
Yes.
So now that's the first one.
So,
I'm saying, hi.
it's more than the 16 you are talking of.
Okay. You say it's more than the 16. Okay.
Because when I look at the plus and use this,
I'm listening.
that
Mr. Jacob,
what
I'm
is
listening.
inside our books, if I get when I count, I get more than 6. I get about 20.
Hey, how are you counting?
Jacob, the combinations in line, he's just counting them as they are combined as one, no? Like in every line.
How
Are
is
you
he
getting
counting
it?
his own? Is he counting the use? Is that what he's doing?
Jacob,
I think so.
don't count the use individually, like the combination as one, a combination as one in that
Are you not
order.
talking of? I'm,
Mr. Jacob.
are you not talking of? We have plus U1 plus U2 plus U4. So even
So
if you
all
take
that is
plus
one.
U1 plus U2 as I'm coming.
So,
So
so
even if
you
you take
consider the
plus U1,
you hello. You consider plus U1 plus U2 plus U3 plus U4 as one.
as one
Then you
combination, is that
come to
not
the
it?
next one.
Yes, do you
Exactly. Then you
understand?
come to
So this is
minus
the first
U1.
combination. So are you
Then you
okay? Do
come.
you understand what you are saying?
And if that's the case, if you also the way you are talking, if I take it line by line, then I'm going to get 10 lines. They are in 10 rows.
No, you are going to get 16. Like that's why
There
I
is
counted it.
continuation. There is continuation.
Continuation to the next page.
There is continuation.
Okay, there's a continuation at the back.
Yes.
All right.
Are you okay, please?
Okay. I'm okay
All right,
now.
sure.
I've seen the continuation.
Okay,
Thank
okay,
you.
all right, thank you. Okay, so that's the first one, and I'm saying the number of combinations to write is because it's just plus. Okay, sorry, let's go to the magnitude. The magnitude of error of random error, right? Now with this particular one, this is just plus. So let's say we just assume with every u there is a one attached to it, like just from like our normal math. Do you get it? So this is one u1, one u2, one u3, one u4. So since this is all positive, now if I'm to add all this, you get maybe plus one, plus one, plus one, plus one. That gives us what? 4. These are you guys okay?
Yes, sir.
Yes. So that's how come we got the 4U here. Are you okay? Someone's hands is up. Mr. Joseph.
Yes, sir. Sir,
Mr. Joseph Anand.
so sir, it means that hello, sir.
Yeah, I can hear you.
Hello, sir.
I
Okay,
can hear
so sir,
you.
it means that we are not okay, sir. Sir, so it means that we are not going to consider the numbers as subscript of the U, like U1 plus U2, the numbers attached to the U. We are not going to consider that.
Yeah, I'm not considering that, yes.
Okay, sir.
All right, sure. All right, thanks. Okay. So okay, so that we've established how we got the 4. And the number of combinations as stated here is 1. It's 1 because it's just positive throughout. Like I'm just going to get plus, sorry, what's happening to this? It's just plus, plus, plus throughout. Do you get it? Positive, positive, positive throughout. So it's like no matter how you change this, do you get it? No matter how you change this, right? No matter how you change this, nothing would really change. That's what I'm trying to say. Like if you have to move this plus to here, move this plus here, move this plus here, like it will just be plus throughout. So meaning the number of combination here is just one. I don't know if you guys understand. Because this is just positive, there is no way you can maybe change the positive here to get a different thing. Are you guys okay? So it's like you are just going to get the same thing throughout. That's what we are saying for this particular one too. I don't know if you guys understand up to this point. You have to understand this before you understand the second one. So this I'm saying with the number of combinations because it's just positive signs. Do you get it? Because maybe the U value is just positive, right? If I'm to change this positive from maybe U1 and bring it to U2, it's still positive. If I'm to take the positive from U2 and bring it to U3, it's still positive. You get it? That's why we have the number of combinations here to be just one. Now, when we come here to the second rule, to the second one, can you see this is what a negative U1. Janet, this is what negative U1. And as we stated here, there is one maybe attached to all the U's. So now this becomes negative U1 plus positive U2 plus positive U3 plus positive 1U4. So now then this becomes what? So like the negative here will cancel the positive here. Is that guys okay? The negative here will cancel the positive here. So now this two, by adding these two, you get what? 0. But then this plus this, that is the 1U3 and the 1U4 gives us the 2 that we have here. Please, are you guys okay? Hello?
Yes, sir.
Hi, Mr. Joseph. Your hands are up. Okay.
Say on the second one that you are doing, so it means
Yes.
that negative U1 was of the plus U2. So it means our focus
Yes.
is on U3 plus 4.
Yes, plus U4. Do you
Okay.
understand? So that gives us the 2. You're okay. All right. Okay. Thank you. So that's for yeah, hold on. Mr. Zakaria, your hands are up.
Okay, thank you, sir. So it means that each lane you have taken, you get plus 2U.
Come again?
Because I said, looking at the combination uncertainty,
Okay.
so each lane you've taken, you get plus 2U, positive
Yes.
2U.
Yes.
Because
Yes.
looking at the first one, the negative is affecting the U1.
Yes.
And then when you move to the second lane too, it has been shifted to the U2 and it's still
Yes.
cancelling.
Yes.
Okay. Okay.
You
Thank
get
you,
it.
sir.
So that gives us the different number of combinations that the negative can change. Do you get it? Depending on the position of the negative sign, it
Okay,
can
sir.
change maybe how the calculation is being done. Are you
Thank you,
guys
sir.
okay?
Thank you, sir.
So it's
Thank
like
you.
in this situation, U1 and U2 are canceling because maybe U1 was negative. Now, when you come to the second one, U2 becomes negative, U1 becomes positive. So that's more like a different combination. The third one, U3 becomes negative. Do you get it? Whereas U2 becomes positive. So that's how come we have 4 different number of combinations because maybe the negative and the positive signs are what switching. So the number of combination is just based on the number of times you get it. The negative sign was alternated. Do you guys okay? Hello, please, are you guys okay? Any question or you guys are fine? We can continue.
Let's continue, please.
Okay, all right, thank you. Then we come to the next one, right? The next one. So you can see 0 here. The 0 is because now this is what negative 1 minus 1, right? So negative 1 minus 1 from our math is what? Minus 2.
Yeah.
You guys agree? And this is positive 1 plus positive 1. That is what? Plus 2. So now you are getting minus 2 plus 2, which is what? Going to be 0. Are you guys okay?
Yes, sir.
Yes, sir.
Yes. And the number of combinations, just as we established, is just based on how many times you can what? Interchange the negative sign and the positive sign, right? So now from here, this is negative U1, negative U2, positive U3, positive U4. When you come to the second one, U1, positive U1, positive U2, negative U3, negative U4. The third one, you get negative U1, sorry, positive U1, negative U2, positive U3, negative U4. So it's like basically how many times we can interchange them, like how many times we can play with the positive and the negative sign. So from this, the number of times you can play with them is what? 6. Do you get it? So like if you have to sit down and do it, you can realize that the total number of times maybe the two negative signs can alternate with the two positive signs in this particular combinations are what? 6 times. So that's how come we have the number of combinations here to be 6. Please, are you okay? Because of time, I want us to
Yes, sir.
rush through this one too. So it's like it's just that straightforward. Please, are you okay?
Yes, sir.
Yes, sir.
All right, sure. Okay.
Sir,
So
sir,
basic. Hi. Okay. Someone has a question. So Joseph, you have a question? I had to say so. Can we continue, please? Hello. Can we please continue?
Yes, sir.
Yes, sir.
Okay.
you can continue.
Okay, sure. All right. So Manita, let's continue. These are all maths. Okay. We'll come back to this one. I want us to do something. I would want to download the this thing, the WPS. So, Mr. Bright, after the class, you would help me get it on my laptop, please, so that next time I can use it to draw. I hope I can use it to draw and all. So I can be using it to draw the Gaussian curve for you guys. So, Mr. Bright, can I use it to draw? Or Mr. Williams, can I use it to draw?
Yeah, once you have the pen on it, you can use it
I
to
can. Okay.
illustrate. Yeah.
Okay, sure. So that's what we do when we meet. So let's just jump straight into the separation techniques, unit 3. So we'll come back to the top ones. Ms. Anita, so let's continue.
All right. So separation techniques. That's the outline. Should I read it?
No. Let's just
Okay. You okay.
well, nah, overview, no. Let's get into it. Yeah.
All right. So session 1, classification of separation techniques. As you have just read from the introductory part, which we didn't read, of this unit, a separation is only possible if there is significant difference between the components of the mixture, either by their physical nature or chemical nature. In this session, you will learn about the various physical and chemical properties of components of mixtures that have been applied to effect their separation. Separation based on size. You might have experienced at home that whenever corn flour is to be freed from chaff, it is sieved. Similarly, whenever a palm soup is to be prepared, it is also separated from the slurry by sieving. Do you know why these separations are possible? The simplest physical property that you can exploit in a separation is size. The separation is accomplished using a porous medium, that's the sieve, through which only the analyte or interference can pass. Filtration, in which gravity, suction, or pressure is used to pass a sample through a porous filter, is the most commonly encountered separation technique based on size. Particulate interference can particulate interference can be separated from dissolved analyte by filtration. using a filter whose pore size retains the interference. This separation technique is important in the analysis of many natural waters for which the presence of suspended solids may interfere in the analysis. Filtration also can be used to isolate analytes present as solid particulates.
Okay.
Okay, so where am I?
Yeah.
All right. Filtration, in which gravity, I think I've read that place. This separation technique is important in the analysis of many natural waters for which the presence of suspended solids may interfere in the analysis. Filtration also can be used to isolate
Yeah.
analytes present as solid. I've read all these places.
Yeah. So
For
is this side
example,
that you are, for example, yeah.
this is a necessary step in gravimetric analysis which you will learn in Unit 4. Other separation techniques that are based on size are di dialysis and size exclusion chromatography, also
Yeah.
called gel permeation or molecular exclusion
So
chromatography.
grand. So quick one, sorry. So this like it's just something that we do in our everyday lives. Do you get it? Separation. So it's like um different analytes, right, require different separation techniques. So basically, that is what maybe this sections will be out about. But then the same way as it's said, we are going to learn more as we go down the line. So it's like even we have the separation based on size and all that, but then we have other means of what determining it. That's why it stated that we will learn more about it in unit 4. So this is more or less like reading in a certain sense. You get it? But then if you guys have questions, you can just be posting it on the page. I would answer as and when I see it and all that. But then basically, okay. So let's continue. Let's continue.
Okay, so separations based on mass or density.
Okay, sorry.
Oftentimes,
Okay. Quick one. Maybe with this one, like examinable questions will be just basically knowing. So, like in this particular case, we've talked about what filtration. Do you get it? So, like separation based on size. It's like you should just know these things. Like, when do we apply filtration? Like those things. Are you guys okay? I don't know if you guys understand what I'm saying.
yeah, we are getting it. So the
Okay.
condition that is needed for us to
Mhm.
apply, maybe when we are dealing with size, then we should know that it should be one of them should be filtration, something like
Yes,
that, right?
basically, yes. All right.
So,
Okay.
uh, yes.
Okay.
Hi.
Abu,
uh, so if I can understand the objective, the first one says that by the end of this session, you should be able to identify
Mhm.
common classification techniques used in chemistry. So in this case, if you are asked, let's say some of the classification techniques used in chemistry, should we say separation based on size or is there filtration?
I don't understand your question. Please come again. Come again with your question. You said the objective, they said identify common classification techniques used in chemistry, right?
yes, that's
Hello?
what he's saying. So
Yes,
what
that was what he
So,
said.
uh-huh,
That's what he said.
so
uh-huh.
he's asking
So,
that
So he's asking
mhm,
that if uh, that you should give examples of classification techniques, are you going to give
mhm.
separation based on size or you give filtration?
Separation based on size.
Yeah, he's asking whether you will mention separation based on size, separation based on mass, or you're going to mention filtration, winnowing, or and those things.
It's like the same thing. So when you say separation based on size, you're not wrong. Do you get it? So like that he said, the common classification techniques. Do you understand? So that one is the separation based on size. Those are the classification techniques used. Do you understand?
Yes, sir.
Uh, okay. No, please you can continue.
All right. Separation based on mass or density. Oftentimes, you decant water in order to retrieve solid particles at the bottom of a container. This is a form of separation. Winnowing is a similar type of separation. You will realize that the two processes are possible because the components of the mixture have different masses. Generally, if there is a difference in the mass or density of the analyte and interference, then a separation could be possible. Centrifugation is a separation method that you encounter in the laboratory and is based on differences in mass or density among components. Your sample, usually a suspension, is placed in a centrifuge tube and spun at a speed. The larger or denser particles experience a greater force and settle faster at the bottom of the tube. Centrifugation is of particular separation technique in biochemistry, especially where the differences in mass or density are minimal. There are various modern versions of the centrifuge that are capable of separating multi-component mixture based on their densities. Separations based on
Complexation. Yeah.
complexation reactions, that's masking.
Okay.
In
Sorry. So
everyday
hold on. So please, with these things, see, in as much as you are reading, how do I call it? You have to just know them, like just like the question. Um, I don't know what's the name. Is it Mr. Abu asked? Do you get it? Based on a question he asked, like these separation techniques, like should be, do you understand? At the back of your mind and all that. Do you understand? Like these are things that you should have at your fingertips. I think that's what I'm basically trying to say. Sure. Thank you. Please let's continue. Okay. Hello. Hello. Am I
Hello,
off?
sir.
Hi.
Hello, sir.
Okay. Okay. It's Miss Anita, are you on the call? You left.
Yeah, I'm on the call, but I cannot see this. It's now back like.
Can you see now?
Yeah, yes.
Okay.
All right. Should I go ahead?
Yes, please.
Okay, so in everyday language, you could consider this method as blindfolding. The components of the mixture that you do not want for a particular purpose. So you do not necessarily remove them from the mixture. Masking is one of the most widely used techniques for. Hello?
Yeah, I'm here.
Okay.
You can continue, sir.
Masking is one of the most widely used techniques for preventing by blinding the interference as preventing it from determination. This process is known as masking. Technically, masking is not a analyte and interference are never. Hello? It's like my network is fucking. Hello?
Yeah, I'm here. We can hear
Is
you.
it?
We can hear
Oh,
you.
okay.
We can hear you.
All right. This process, okay, technically, masking is not a separation technique because the analyte and interference are never physically separated from each other. You will, however, many at times require masking in analytical chemistry. A wide variety of ions and molecules have been used as masking agents. Table 3.1 below shows some of these selected masking agents. So we have the masking agents and species that can be masked. Sir,
Okay, hi. Sorry. So let me
the
just
table.
yeah, this is the table. Let me just brief you. So okay, sorry. So the separation based on the complexation reactions. So we are saying we have we have masking agents. So basically, what we are trying to say is we have the masking agents, like in a situation whereby maybe you have two right species. So let's say how do I call it? Let's say iron, right? Maybe iron and zinc in a particular mixture, in a particular complex reaction. You have iron and zinc, right? You have to just find a masking agent. So the masking agent will simply what mask one of the species, right? And on like it will just mask one of the species. So assuming you are supposed to separate iron from zinc, you just have to find a masking agent which would be suitable to either mask the iron or suitable to either what mask the zinc. That's what we are saying. So iron and zinc, if you have to take this as the masking agents, right? You can see that what it can mask both iron, which is here, and zinc which is here. So meaning we can't use this as what a suitable masking agent, right? Now you choose this one. You can see that you would have the same iron here. You have what you have zinc here. Sorry, you have zinc here. Are you with me? So meaning this won't also what be suitable to to mask any of them. Then you come here, NH3. You can see that you have iron here, right? But then you don't have zinc here. So it means that in a mixture where you have iron and zinc, you can use NH3, right? Which maybe we all say ammonia to what mask the iron, right? So we can what obtain the zinc. Please, are you guys okay?
Yes, sir. So that,
Yes, sir.
sir, does it
Hi.
mean you are meaning iron will not be seen in the mixture, like you are covering it or something like that?
Yes, basically it's like you are covering it. Yes. Do you get it?
Yes.
All right. Basically, that's what we are saying. So are we okay, please? Are we okay?
Yes, sir.
No, sir.
All right. Okay.
Okay.
Okay. What don't you get?
A lot of people do not understand what they're saying.
So we
Okay.
did not get it too.
Say the table.
Yeah, this is the
Because
table.
when you look at the table,
Yes.
so when you look at the table, we have the maxing agent, and then we have species that can be
Yes.
maxed. So
Yes.
if you take CN minus, it has given
Yes.
us various substances that can be marked using the CN
Yes.
minus.
Yes.
But in your explanation, you were using zinc and iron.
Yes. So what
And so
I'm
that has
saying
brought the
is, right?
confusion.
Okay. What I'm saying is the masking agent, right, would mask particular species. Yeah, we've established that fact, right? Are you okay? Hello?
Yes, sir.
Yes. So now
Yeah,
I'm
we are
using
okay.
zinc
Go on.
and iron as what an example. That let's say there is a mixture of zinc and what iron, right? We have a mixture of what zinc and iron. That's the mixture we have, zinc and iron. And we are saying we want to separate maybe the zinc from the iron, right? The question now becomes maybe which masking agent. So maybe you first have to establish the fact that you need a masking agent in order to be able to separate, let's say, the zinc from the iron. Do you get it? That's the first thing. After that one, the second question is which masking agent will be suitable to mask what the iron in order for us to obtain the zinc that we are after. Do you agree with me?
Yes, sir.
Hello. Yes.
Yes,
So
sir.
That's why I said, so the first step, you have the CN here. Now, if you look at the species that it can mask, you'd realize that there is iron here and there is what? Zinc here. Do you get it? So meaning in the mixture of zinc and iron, CN won't be a suitable masking agent to what? Just mask the iron for us to obtain the zinc. If you had to use CN as a masking agent, it would mask both the iron and the zinc. That means at the end of the day, we wouldn't be able to achieve our goal, which is to what? Extract the zinc or separate the zinc. Please, are you?
Sir, my phone is going off, so it means I'll be going off. Hello, sir.
Don't you have
Any?
charger?
So Helen, you inform him, and my phone is off. Is going off, so
Don't you have charger?
I'm not in the house yet.
Where are you?
I think set is off. Oh.
Is going. I think the time is
Nazif, don't look front on yourself. Uncle.
Olafsona. It's even time.